Good afternoon. Quickly give me a second. Let me configure my audio settings. Can you all hear me now correctly? Right. Thanks. Okay, great. Okay, so welcome to the second session. I hope some of you may be joining this week as the first week, which couldn't be achieved during the first week which we had last day. Welcome everyone. So let's continue our discussion on the business mathematics and statistics. We are going through the lecture number 2 today. If you could recall, I earmarked 11 subject areas for you to go through with me on this curriculum. And the very first lesson that we covered on the initial week last week, that was on the introduction part. Yeah. So what we are anticipating today is to cover up the second portion of it. I mean, we had discussed heaps of theory, definitions, what is statistics, what is types of data, sources of data, so much more things during the last week. So the today's focus will be to learn what is called the sampling. Now, students, if you really look into the gravity of the lesson that we are going to learn today, that is sampling, you don't really get maybe a complete 20-mark question or maybe a portion of it on the face value of it. Yeah, because if you really look into the past paper per se, there are many more areas to be tested, like net present value, dual or multivariable analysis, cost of capital, portfolio theory. So these are questions that you may typically see a good 20-mark question. I'm talking about the history on the past couple of years of examination. But this is very important. That's why we are spending a complete day on here and going to learn the techniques that we are going to use for sampling. It's merely because of the fact that there are a lot of MCQ questions in your examination, some of open-ended questions, and some questions in the last elective question, that is question number 8, where you will be comfortably in a good position to score maybe 5 marks or 10 marks depending on the question. What is that last question that we are discussing here? That is the question number 8, typically, where you have some open-ended answers to be given on various definitions of statistics. It's not necessarily on the basic definition, it could be on anything. The examiner can ask creative questions like compare and contrast between two elements, or maybe give a brief description about something likewise. So there are, I mean, that question really, no one can really be predictive about what is going to happen, but if you really look into the past couple of papers, you may see at least one or two questions coming from the very basic areas that we are learning on the lesson number 1. Yeah, so that's the target for the day. We will spend the complete 2 hours on learning what is this sampling. I mean, why do we do that? As in, is it necessary? I mean, can we really go to the mean, median, and mode and discuss about linear regression, go to probability theory? And now, students, all these subject areas that we are going to discuss on the third session onwards is getting a stepping stone or a starting from today's lesson. As in, you and I, we discussed 2 words during the last lecture. That is one thing called the population and the other thing called the sample. Yeah. So we understood that, okay, if you put everything into one particular basket, let's say we want to discuss about the entire Sri Lanka. You put everyone, 22.6 million population, into one particular basket, and then we discuss about that. So that is called the population. But if you really want to take a small portion out of it for a study, now for that portion we call it a sample. Now, how do you do that? What kind of methodology that you can use to select that small portion? That is what you are going to learn today as sampling. Now, even if you take any other lesson, like probability, like linear regression, any of them will have the starting assumption that whether we are discussing about a sample or a population. Yeah. If at all a question is going to tell you that these data set is being collected for the sample, then your set of equations that you're going to apply under the statistics theory is going to be slightly different from if at all you're given a sample to study or a population study per se. Yeah. So that is the stepping stone. That is the whole idea of why we are learning and what we are learning under the sampling methods. Yeah. Typically, I take a moment to brush up what we learned last week. So if at all, I mean, since we are at the very couple of initial sessions, let me quickly try to do the same and spend maybe not more than 5-10 minutes to brush up your knowledge on what we discussed during the very first week. Yeah? So let me finish this and then we will start up with the today's lesson. First, we discuss about, forget about this curriculum and the structure and the class example. Let me quickly jump into where we started and what we completed last week. Yeah. So except for these red underline sampling methods that we are going to learn today, we discussed all the entire introduction part during the last week. Yeah. First, we discuss what is statistics. It is nothing but you collect, organize, and present a set of data. Why do we do that? To come into conclusions, to make decisions. Yeah. So if at all anyone asks you what are the few basic steps involved in statistics, these are going to be your answers. You collect data, you organize them, then you analyze them, and finally you come into conclusions. So now this particular part, organize them and present them. Now this is going to be our next lesson, lesson number 2. This is a very simple lesson, mind you. It's all about how to put the set of organized data from a table to a graph, a pie chart, a bar chart, multiple bar chart. But bear in mind, you may recognize that the 11th subject area, that is the analytical writing. I have explained you that we don't really have to go through a sort of like a language lesson. Rather, I assume that you all are at a certain level of your careers and academia where you can do a write-up in an organized manner. But for that write-up, there are ingredients. Sometimes you have to do a bit of an analysis and present a set of data. Now, that's why we spend the lesson number 2 during the week after in order to understand what sort of graphs and charts and tables where you are going to use during time to time. I mean, we all know that you can put everything into a Excel or a PowerPoint, and easily those software can convert any table into a nice graphical representation. But in my students, this is where you are at the fundamental level. You need to do it using a pen and a pencil. Yeah, that's why we are learning on the organizing part at the lesson number 2. Right. With that subdeviation on my explanation, we understood that statistics can be having many characteristics and it has many importance and usages. You don't have to really spend much time over here. We understood that it's heavily used in many decision-making instances, such as many production to operations, sales and marketing, human resource planning, financial planning, investment decision making. So there are many areas that you can see statistics under play. Importantly, we discussed that sometimes you may see that misrepresentation of statistics can come into a bit of giving bad examples to your audiences. Sometimes, if at all you put up misleading data, maybe you have 3 observations and 3 out of 2 is a positive, then you say it's a 66%. Okay? So likewise, there are few instances which you really shouldn't do. Misleading, elaborating, analyze data, using unmatched data for comparison purposes, taking biased samples, recommending merely based on inadequate and observation. Now, these are some of the instances where you should understand that misrepresentation of statistics is going to not to do any justice to your audiences. Then we came into the idea of what is data and information. We all know data is merely raw, unorganized matter. Then we process them, and finally, it can be information. Yeah. So statistics data and statistical data, statistics are nothing much. These are some definitions which we discussed during the last week. And then we did some exercises to try to segregate between data and information. And then we came here. Types of data. Merely it could be qualitative and quantitative. So the qualitative data can be nominal and ordinal. Quantitative data can be discrete and continuous. What are these? Nominal is nothing but you have some, let's say, red, green, blue, or gender, where you don't have a real order. Then again, they are qualitative, not numerical. Ordinal data, on the other hand, also qualitative, but they follow a natural order, like January, February, March, maybe Monday, Tuesday, Wednesday, likewise. Just give me a second. Excuse me. Sorry. Yeah, so back. So this nominal and ordinal are the two basic building blocks of the qualitative data. Then we moved into quantitative data. These are where numerical, numbers-oriented data, like where you see in any mathematics or statistics-oriented data set. Discrete data, what are these? These are data that will not have any portions or halves. Maybe you may see from 1, 2, 3, and 4 likewise. It could be 1, 1.5, 2, 2.5 likewise. But what is the difference? So between 1 and 2 or 1 and 1.5, there are no any other subdeviations. Yeah. But when you come to the continuous data as well, the only difference is that it has many infinite number of data points in between. Say between 1 and 2, there could be 1.1, 1.111. Likewise, it will not have a limit. Those are the two broader types of quantitative data. Primary and secondary data, these are sources of data, nothing much. Primary is where you take data from scratch, and the secondary data is someone else's publications or usages. Then this is where we stopped. We learned what is a population and a small portion of it as a sample. And then we came here with the intention of learning these 8 different sampling methods for the today's lesson. Okay. So that is where we are. We discussed some of the questions and we understood that these are nothing but some qualitative questions which you can see in the part number 8 typically in the previous examination. Okay, we can't really predicting what the exam questions is going to be, but nonetheless from the very introductory part you may not really see a 20-mark question unless for a quantitative question in this paper. Okay, right. So that's about the previous week. Now this is what we are going to do today. The two broader types of sampling styles, non-probabilistic and probabilistic, obviously is going to be the complete day. That is what we are going to learn under the sampling. But then again, there are some sampling oriented issues that you can observe in the real world. Now these could be sometimes let's say some issues that are going to come up with the natural order of sampling, and some of them could come up with due to the nature of the data set. Some may be due to people are not giving you the good responses, people are staying silent. Likewise, these issues are also going to play a vital role. So we need to understand, okay, although we do a sampling, we can't really be happy on saying that it is going to be the good representation of the complete data set. And lastly, we will spend good time on the past paper questions. There are ample number of past paper questions coming from the sampling. We will discuss one by one and we will wind up for the day. Okay, with that plan, now this is the structure of what we discussed last week on the sampling methods. Now again, if I quickly try to take your memory back, why do we do sampling? We need to take a small portion of data from the entire population. Why do we do that? Simply because of the fact that sometimes we may not have access to the complete data set. Sometimes we may not in a geographical position to go and collect the data. Sometimes it may be costly. Sometimes due to various practical reasons, you may not get the access to the population. So the whole idea, students, if at all you have the access to the population, the sampling is not going to be a necessary thing. I mean, obviously, if you know, look at our class example. We previous week we discussed about 70 students class. Now that is going to be my population, isn't that so? What I was intended to do at that time was that I really want to design my slides in a way to understand in a better manner to my audience. So as a part and parcel of it, I want to understand the mathematical knowledge of my students. So what is my population? That is 70 students in the class. Do I really wanted to, do the analysis of understanding the mathematical knowledge of entire students outside? No, I really want to focus on my class. That is the 70 students that I'm focusing. Yeah. So with that, in that case, in fact, although we discussed that we are going through a set of selecting a small sample, so and so, but we really didn't want to do that. If at all we have the access to the complete 70 students. Now imagine, now that is a lucky scenario. I had 70 students in one class in front of me. I have the access to the population. But all the other cases, if at all I don't have the access to the complete population, then only the statistics is going to discuss about a sampling. Right. So broadly, now we all understand that if at all there's a population with 70,000 and I need to select 70 out of it, then obviously I have to make a choice. I have to find a way. I have to find a mechanism. I have to follow some natural order to select that 70. Now these are the two basic broad structures of that you can follow in such instances. The first branch, we call it as a non-probabilistic sampling, and the second branch is a probabilistic sampling. What does these names is going to imply you? I mean, the word itself is going to give you some meaning. Probabilistic, that means there should be some probability-oriented mechanism to select this sample. Now, what about non-probabilistic? Obviously, there won't be any probability-oriented methodology to select my sample. Yeah, probabilistic and non-probabilistic. We have a complete lesson on probability, don't worry. But what is probability? It's simple. Whether you give some sort of a chance to be chosen. If it is non-probabilistic, that means, okay, there seems to be no probability-oriented selecting, but it could be various other selection methodologies. Yeah. So the 8 different sampling procedures that we are going to discuss are called, let me take it one by one: convenient, judgment, quota, snowball. Now these are some examples of non-probabilistic sampling. Are these for the only for non-probabilistic sampling? Not at all. There are many more. But then again, we are learning on the very essential or very widely used methodologies under the curriculum. So we have selected these 4: convenience, judgment, quota, and snowball. About the probabilistic, it could be simple random, systematic, stratified, and cluster. Once again, I reiterate, these are also 4 out of many other probabilistic methodologies, but these are the widely used and mostly utilized ones. Right. The broader idea of non-probabilistic sampling, students, is that it is not essential to know information about the population. What does this statement is going to tell you? That means you don't really have to analyze and understand how many items are in the population, the nature, the geographical dispersion. No, it's not essential. If you know it, that's fine. I mean, knowing the nature of the information on the population, still you can use non-probabilistic sampling, no harm, but it is not essential to know. This is a sampling method where it is not possible to specify the probability that any person or unit on which the survey is based will be included in the sample. What is that idea? That means that is where I'm going to make this demarcation. I mean, the probabilistic sampling definition would be the reciprocal of what we are learning now. If at all I am going to give an equal chance to all the items or persons in my survey, then such instances we call as the probabilistic. If at all I'm giving the equal. Now in here, it is not possible to specify the probability. Let me highlight that one. It is not possible to specify the probability. That means for a certain item, the probability may be higher than the other item. Let's say I take, let's take a simple dice with 6 sides, something like this. Now I have sides marked like this, 1, 2, 3, 4, 5, 6. Now what is the probability that I'm going to get one particular number? Assuming that this is an unbiased dice, that is going to be simple 1 out of 6. So if at all I'm going to take these numbers into my sampling this thing, that is going to be nothing but a probabilistic corrector, because I am in advance I'm knowing the fact that okay, there are equal chances for all these 6 items to be selected in my sample. But what if I really don't know the nature of my data set? I have no idea. Certain items will be dispersed in a inaccessible place. Certain items I even don't know whether they are existing in my population. So such instances, students, I don't really have to go through a mathematical method. So these are merely qualitative methods of sampling where you're going to select the sample based on various qualitative factors. Before we go into the individual items, let's discuss some of the key advantages and disadvantages of this. So the easiest would be the easiness. In a purposive manner, it's going to be very easy and very flexible to select this sample. If at all you're going to take a probabilistic sampling methodology, what is going to happen? And that means you have to know information about your population. You have to make sure that individual item is going to give a similar probability. You can't be biasing anyone. So those methodologies are going to be costly, time consuming. But in contrast, all these non-probabilistic sampling methods are very easy, very flexible, and you can do in a purposive and a selective manner. You may see, okay, you might think that fine. Is this a good sampling methodology? Of course, it may not be the best one, but given the circumstances, this may be the only methodology sometimes the researchers have to follow. What are the key disadvantages? It is all about this non-representative issue. If at all you know that my population is going to be comprising of this area, and I am going to take a sample like this out of that population, you may know that okay, I have given an equal chance for this portion to be selected. But if at all you, let's say, now this part is open, this area is going to be going to this unknown territories. Yeah. So from this slide, that means this, let's say, sometimes it could be coming into different directions. You assume that this is my only data set, but there could be, if you take the actual, it could be a broader data set like this. You have an assumption that my data set could be something like this or this, but then again, you are not really sure. In such instances, you are making this non-representative error. What is that? It is nothing but you can't take a valid estimate about the total population because the sample selected is not representative. If at all you follow the probabilistic sampling method, we don't have this problem. Okay, so that's about the probabilistic sampling methodologies. Now let's take one by one and learn what these interesting methods are. The first one, that is a convenience sampling. Convenience sampling. The name itself going to sounds like, I'm going to select my sample based on my convenience. Pahasukama. That is the whole idea. That is the whole idea. Members of the population are chosen based on their relative ease of access. Ease of access. Let me highlight that word. Relative ease of access. Analysis can be conducted by what was convenient, not by random. See, not by random. If at all a random methodology is being used, it's a probabilistic oriented one. Also called haphazard or accidental sampling. Now look into this image for a moment. The guy under the symbol of a red man is our researcher. Now he has selected this particular area as his sample, and we are going to call it as a convenience sample. What does this going to imply you? He hasn't reached this person. He hasn't reached this person. Not this person. Why? It's not convenient. It's not convenient. Convenient as in, this could be maybe due to geographical disbursements. This may be the Western province. He is in Western province, and the next person may be in, let's say, somebody from Northern province. He don't really have access. Somebody from different other, let's say, Eastern province, he may not have access. But all the close by provinces, he may have gone and collected data. If you really look into your early days of studies, your O levels, A levels, isn't this what we are going to do all the time? You start with the assumption that, okay, I'm going to study about the general public who are traveling in the buses, their problems. This is your assumption. You go to the, let's say, PETA, the general bus station, and then you try to talk to a few people and gather data. And then you conclude the survey saying that, okay, I discussed with people who are coming from different parts of the country, I discussed their problems, and these are my findings. But didn't you forget the fact that you could have visited some more bus depots like in PETA? You could have gone to the Northern province, go to the Central province, go to Galle, Matara, different areas. You should have do the same thing. If at all you are going to select a complete nice sample out of this entire population from the small country Sri Lanka. But nonetheless, all what you did was you went to the PETA station with the assumption that you're going to get different people from different areas. So typically students, a lot of our early days surveys, studies, sampling technique that we are going to use is nothing but this convenience sampling. So this convenience sample is one of the very easiest and less costly and the fastest way to do. So the relative ease of access is the keyword to remember. If you look into the picture, what can you see here? You may see, okay, fine. This researcher has selected these 4 elements. There are 3 elements in the green representation and 1 blue. But what I have highlighted here, no purple figures in the sample. Now see the risk. For the convenience purpose, he has gone and select data from these chaps. But for this population, if you really look into, there are blue, green and purple elements. But for his sample, he has only selected blue and green. No purple figures are selected in the sample. So see the issue. Did we discuss this somewhere over here? And not representative, the key disadvantage. See, if at all this sample to be representative, what do you need here? At least one purple figure to be included in the sample. Now, this is the typical problem of convenience sampling. Although it is very easy, it's relatively very comfortable to collect data, but then again, your sample will not have the complete representation of the population. Okay, fair enough. It's pretty easy to understand. Second one, judgmental sampling. This is also another form of convenience sampling where the items are selected from the accessible population. Now, one may see, okay, what's the difference between this and the convenience sampling? So, convenience sampling students, the important thing to identify is that the researcher selects the sample based on his or her convenience, easy access, practicality. The judgmental, the keywords to identify or keep in mind are nothing but these are hand-picked items. These are hand-picked items, selected items. Highlight that part, hand-picked from accessible population. That means, okay, not the entire population. If I do justice here, the entire population may be coming with this particular area that I'm highlighting. This is going to give you implication, okay, the population, there are more to come. But this is the accessible population of this researcher. This is our researcher. Yeah. So what is he doing? He's going to select a set of items from the accessible population. Please look at the second bullet. Researchers select items that are representative of the entire population. He thinks, he believes that, okay, fine, I believe that the entire population is going to be representative by this selection. Once again, it's going to be a very subjective sampling method and it can be biased. Why? There are no probabilistic orientation. There are no, what do you call, the same opportunity being given to the entire population. Look at the body, another form of convenience sampling where the items are handpicked from the accessible population. So remember, there are parts of the population which are not accessible to the researcher. So there may be some important elements he or she is going to miss to collect data. So this is also going to be a very straightforward and a very easy thing to understand. What's the, again, I reiterate, what's the difference between the judgmental and convenient? Convenient is merely the access, but here, yes, also you have the access, but from those accessible population, you are not going to talk to everyone, you're going to handpick a certain set of people from the accessible population and call it your sample. So this is going to be your sample. Once again, okay, fine. One could say, okay, what's the whole idea? I mean, both are convenient sampling. True, of course, true, but these are minor differences that you should keep in mind. Accessibility and selecting from the accessibility based on your judgment, Okay. The third one, the quota sampling. Right. The word quota is going to give you an idea, fine, some sort of a proportion or some sort of a allocation should be done from a methodology after following. The quota, I mean, one couple of words that you can come into mind when you say quota. the apparel-oriented quota for the European Union, you may recall, okay, for the different countries, they have a quota of different items to be exported based on a certain methodology followed by the European Union and the Western part of the world. A few more words for quota. During the very early 1970s, when there was some crisis in the country a couple of decades ago, you and I, we could recall that our parents may have got a quota for rice. You have to go to one of these cooperative societies, and based on a particular identification, you may have a quota of rice, maybe 2 kilos or 3 kilos to buy. What is this word quota is going to tell you? Quota is nothing but an apportionment based on a criteria designed by someone. Yeah. So this is having some relationship for the one other sampling methodology that we're going to discuss in a little while, that is called the stratified sampling. The stratified sampling and quota sampling are going to have a bit of a similar characteristics, where the population is divided into mutually exclusive subclasses. What do you mean by the word mutually exclusive? It's a word that we are going to learn under the probability, but for the moment, to give you a brief understanding, the word mutually exclusive means you can't happen, you can't occur, you can't stand at the same place while you belong to another place. That means, let's say you're a singer and you're a guitarist. If at all we are clustering everyone into, okay, singers to the one side and guitarists to the other side, you have to select one and be classified as either a singer or a guitarist. That means you can't, yeah, true that you have the both characteristics, but under the stratification, when you're making the population into different stratas or groups or classes, you have to be belonging into one particular class, and you can't have both qualities at the same time. Fine. Second bullet point. Then judgment is used to choose the items from each stratum or each group or each batch based on the specified proportion. The important part is this specified proportion. Last point, difference between stratified and versus the quota sampling. Stratified is the one that we are going to learn in a little while, that will come under the probabilistic. Quota is what we are going to discuss here. The stratified requires a random sampling where for each strata, while the quota does not require so. Fine. Bit of a confusion, isn't that so? Let's try to understand with this particular image over here. Look at this particular population. We have 50% male and 50% female. Okay, 50% male and 50% female. And 70% white and 30% black. That may be the skin color. So 70% white and 30% black. Now these are the data given about this population. Now, what the diagram is going to tell you is that there are 10 items here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. If it is 10, that means there has to be 10 on this side also. White is 50 and 50. And out of this, 70% are white. That means 7 white and 3 black. For the ladies also, 7 white and 3 black. Now look at the word mutually exclusive. You don't see these classes occurring in the same time. You can't have like this. You have to stand on one particular group. Now where are the groups? I can see one group over here. Let me use some different colors for you to be clear. I have another group over here. Then I have a third group, something like this. Lastly, Now, these are my 4 strata, so 4 groups or 4 classes. Strata is nothing but a word for the same word, same idea of groups. Now, from these groups, what we have done here, we have selected a quota of 50 males and 50 females. Okay, so that means from this sample, you can say, okay, 50% is male and 50% is female. Graphically, it is correct, right? 2 men and 2 women. Representative of gender distribution in a population, not representative of the race. So you may see, okay, fine, a quota is being given as 50-50, and the sample to be more effective, they have chosen 1 white person and 1 black person from each gender. Isn't that so? What is this wording is going to tell you? If at all you may, let's say you may have selected something like, let's say 5 person like this, versus in this instance, what is the difference that you can see? Now in such instances, let's say you may have to select 3 white and 2 black for the race population or the race distribution to be equal. But here, since you have only 2, for this particular selection, they have select 1 white person and 1 black person. So it is going to be very much effective as per their belief. So there are no, I mean, for this quota sampling, once again, there are no scientific methodology or the distribution to have a scientific mechanism to select this particular quota from the population. It is not necessarily so. You classify them, you cluster them into different groups. Once you have those groups, all what you can do is that from each group, you select 1 or different items depending on your choice. I mean,
yes, sir.
Right, excellent. Okay, sorry about that little interruption. Fine. Okay, so this is the whole idea of quota sampling. We cluster them, we put them into similar groups, and then from those groups, depending on your choice, depending on your selection, you can select a quota-based sample. So one could ask, okay, can you select one particular methodology for quota and multiple measures? Of course, it's perfectly flexible. Now look at this example. Here, the gender is the quota that you have defined. For gender, you have selected 50% male and 50% female. So is it going to be all, I mean, since there are 2 classes, is it going to be only 50-50 all the time? No, not necessarily. You can, I mean, looking into this particular 20 persons population, you can say, okay, I'm going to give 70% male and 30% female population. That's perfectly up to you. So likewise, one can ask, okay, can't we give a population based multiple criteria to be selected quota? Of course, that is also possible. You can say, okay, I'm going to give you 50-50 male and female, and again 70-30 gender-based, sorry, the race-based quota. So your quota can be having multiple characteristics based on your choice. Okay, once again, whole idea where we will learn from the difference between the stratified and quota at the stratified instance. With that and this, the only difference is that you are going to do the selection based on your judgment. The second bullet point, important, then judgment is used to choose the items from each item based on the specified proportions. The proportions and judgment, it's perfectly up to you. Okay, that's enough on the quota sampling. Right. The last one that we are going to discuss under the non-probabilistic sampling is the snowball. snowball sampling. Uh, I mean, in physics, in real world, you may see, okay, a snowball, a big giant snowball, is sometimes created not the entire snowball at once, but as a very tiny amount of snow at the beginning, and then more snow being collected to that particular portion, and then it moves on and on and on and again. Like in a hill country, in a rainy day, the river, you may see the similar thing, what we call as a flash flood. The flash flood doesn't occur at once, but from one tiny drop of rain to the next tiny drop of rain, they all accumulate one by one, one after the other, and then they create a giant element. That's the nature what we can observe. The snowball sampling is a similar methodology where, once again, we discussed at the very inception, the convenience sampling is something that you and all are doing very much often. Now, this one also, I can quote the same methodology. We do this quite often. How do we start it? Before reading the text, let's try to go to this diagram and try to understand something here. Now, this is you're here, you're the researcher. You create a questionnaire and then you give it to two persons, P1 and P2. And then ask them to fill it and get it back to you. Once they give it back, you tell them, okay, thank you very much. Can you just forward this survey? I'm a university student, I'm an IBS student. Can you just forward this survey kindly to a few more people to collect the data? Then P1, give it to three more people. P11, P12, P13. Similarly, P2 also does the same thing. P21, P22, P23. Now, these are all going to be created to a giant snowball. If they continue this pattern, if then they go to the next levels like this, then there is going to be a huge sample that is going to get collected. This doesn't necessarily imply that this sampling is going to give you a broader access to the data compared to the other methodologies that we discussed. It's not necessarily the case, but this is how your sample is been selected, how it has been formulated. The snowball sampling. First bullet, a non-probability sampling method where existing study subject recruits future subjects from among their acquaintances. So the whole idea is that you sort of like a pyramid. You start with the top, and then when you go to the bottom, very bottom, you go to multiple layers of people being acquiring into this particular data set. This sample group grows like a rolling snowball, where the first respondents refer to a friend, then the friend also refer to another friend, and so on and so forth. So once again, this is also a very practical methodology where it's very easy. And if you really use one of these, let's say Google Forms or something like that, back then we used to do something like a Survey Monkey, Lime Survey. I mean, those what we had before the Google started their own nice product on this Google Forms where you can easily collect data. This is all what we did, isn't that so? We create this and then we forward it to 20, 30 people and we plead them, can you kindly forward this to more people? And assuming, now look at the danger. When you, now if at all you do the convenience sampling or the judgmental sampling, you have some, control to select what items are going to come into my sample. But look at the danger here. It's very easy, it's very convenient. You get a lot of people to respond. But let's say, now you are targeting about the university students, let's say particular appetite towards the subject matter. But you may get some responses from unknowingly from maybe a schoolboy also. How can that happen? Because they referred to n number of people in the bottom of the chain. You really have no idea who is going to come into your particular sample. Isn't that so? So, I mean, is this a good methodology for sampling? Of course, it's a very practical, very easy to utilize methodology, no harm. But then again, do you, I mean, compared to any other methodologies that we are using, like the convenience and all, does this carry a risk of items being selected to the sample? Of course, it has some sort of a risk. But merely if at all you're taking, I mean, you're trying to, access qualitative research, where it doesn't necessarily involve the subject's technical competency to answer the questions. Such kind of a research, it's very harmful to practice something like snowball sampling, where you may select, I mean, like these popular radio channels, where they try to talk to few people and ask, okay, what is their favorite radio channel? So for such kind of a question, you don't really have to have a some sort of educational background or anything like that for that particular question to be answered. So such kind of a sampling methodology, fine. Snowball sampling is not going to give you a major harm. It is something that is being practiced in the entire society many times and in many instances. Okay, quick brush up. Convenience, depending on your relative ease of access. Judgmental, again another form of convenience, but then again you handpick based on your preference. Quota, you group them. For those groups, you give a particular quota based on your judgment. Snowball, you refer to the first person, and then that person refer to the second person, third person, so on and so forth, and the snowball keeps on growing. Okay, these are the non-probabilistic sampling methods. Right. Now we are coming to the probabilistic sampling methods or probability-based sampling. Now for here, those sampling methods, you need to know information about the population. You cannot merely practice probabilistic sampling if at all you don't have a perfect idea as to what your population is going to be. Look at these two bullet points. Certain items of population under consideration can be underrepresented or overrepresented. Why? Let's try to discuss a little bit here. Can be underrepresented or overrepresented. Let's discuss second bullet and also then come back. To minimize the above selection bias, target population has to have an equal opportunity for selection. Yeah, we call it as a selection bias. Now, if I take, let's say, a good example, let me quickly go back to this picture. Now, in this picture, forget about the researcher. Let's assume that this red color icon is not here. And let's assume, try to do a quick brush up. Let's assume now, okay, this blue area is the convenience sample. Forget that part for a portion. Let's assume that this is going to be my population. And I know that I have to collect the data from this part. Okay. Now, if I use any probabilistic method, students, now what is the probability for this person to be selected? It is going to be, if I just name it as, let's say, 3%, for instance, it is going to be 3% for this person also, 3% for this person also. Likewise, it is going to be equal number for any person to get selected. Now, let's say I'm going to select 5 particular items from this population. Okay. Okay, I select the first one. I get this person. Fine. Now, what is the probability for the next person? The probability doesn't really change. Why? It's equal probability. Not the convenience methodology, but I'm just using this diagram for you to show the problem that I'm going to face. So, all the other items, equal probability. And the next person, I get this man. Okay. Third person, I got this person. Fourth one, I got one over here. And the fifth one, I got this person. Okay. Fine. Now, if I just try to put them in a order to show you what my outcome, I got 1, 2, 3, and 4 green men and 1 blue man. So what's the problem? So this population seems to be having some, equally diverse set of colors of green, blue, and purple. But then again, I practice a probabilistic methodology. So each item, I have an equal probability, no harm, no problem. But then again, unfortunately, my sample got selected with this particular nature. Uh, to make things very interesting, let's try to get the fifth person also something like this. This is the fifth person. Now, what is my sample? I have 5 green men. Now, if I just try to make a decision just by merely looking at the sample, what is the problem? I can only think, okay, the green is the element that is in this sample. Why it is going to happen? It is because of the fact that due to the probability, equal chances are going to come into the picture. So certain items can be overrepresented. Certain items can be overrepresented. And on that discussion, what about purple and blue? They can be underrepresented also. So earlier I had green, let's say 30%, red, let's say 40%, and blue 40% and purple, let's say 30%. Now altogether it is going to create a 100%. Let's assume on that particular diagram, this was my dispersion. This is how the data has been dispersed. Green, blue, and purple, 30, 40, 30. But unfortunately, after practicing a probabilistic sampling, since every item is going to get one equal opportunity, I got green, 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 and green. Now, okay, I know that the population has many more colors. Unfortunately, for my sample, I only got green. So certain items can be underrepresented, certain items can be overrepresented. One could ask, okay, if the probabilities are same, then how can you get 5 green items in the first go? Fine. So the second go, you may have a different set of items, maybe green, blue, green, purple, green. Now this one seems to be a good one. This sample is going to be a bad one. Another sample, I'm going to take blue, 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 purple, blue. Again, a bad sample. Why? No green elements. Now see, by merely practicing a probabilistic sampling method, students, you can't really be happy and say, fine, I've done on the maths, I've done on the stat methodologies, and this sample is going to be a good sample. You can't really be happy. Why? The selection bias. Because of the fact that all the items are going to have equal probability, this issue cannot be resolved at all under the probabilistic sampling. So we assume that equal opportunity, if at all in the target population, equal opportunities are there to be selected, these kind of biased samples will not be there or will be minimized. However, you can't really guarantee that probabilistic sampling is going to give you the best. There's nothing like the best out of these, any 8 methodologies. There's no the superior or inferior. All are different methodologies. Fine. Let's try to learn the 4 different sampling methodologies under the probabilistic methods. The first one, simple random sampling. Now, this is known as the widely used probabilistic oriented sampling method, which are used in many surveys, many research. Simple random sampling. All items in the population under consideration, will have the chance of being selected based on the probability. For example, you can use a random number table and pick n number of fairly random selections out of the population capital N. Example, using a random number table, selecting the second and eighth items, etc., from the population to build the sample. This text is going to talk about the elements over here. What are these? This is the items in your population. This is your population. And this is one particular sample. This is another sample. Sample 1, sample 2. Now, here students, you see these 12 elements as your population spy. But for you to select 2 out of these 12 elements, you have to practice some sort of a methodology. So under the simple random sampling, what it does is, it merely takes a random number generation mechanism. Random number generation mechanism. Now, I think I remember your calculators also have this function as RAND. When you press that, it will give you a random number between 0 and 1 with decimals 0.1, 0.2, likewise. Does it have some sort of a mechanism to choose that number? No, not necessarily. No, not at all. It's a pure random selection. So if you take sample number 1, this item number 2 and item number 5, how are they being selected? Is by merely taking up the numbers that has been allocated to them. One classic example that you and I can see in the real world will be something like a lottery draw. Something like a lottery draw. So it's not necessarily selecting items from population to the sample, but you let's say you have not this lotteries of this Shanida Vasana kind of things, but let's say you're in a party, you have 50 people in your company, and then you want to select 3 people to give some gifts of participating. So you give some equal numbers, some sequence numbers based on their attendance or based on their registry or employee list. And then you give number 3, number 10, number 11, likewise, but only one person will have one number. And then you go and take the microphone and announce, okay, let me call number 31, number 1, and number 7 as the first, third, and second. Now, how do you select those 3 people? Kamal, Nimal, and Sunil will come to the stage. How do those 3 came? It's merely because of the random number allocation. So that doesn't necessarily have to have an order to allocate, necessarily have a scientific method to give 1, 2, 3, 4, 5, 6 up until 12 the way that they are, not necessarily. But one person, one number, and from those numbers, there will be a selection methodology. So from that selection methodology only, the persons will be selected. The statistical methodology, simple random sampling, is going to suggest you it is going to be nothing but the simple random sampling. That means the selection, these 2, 5, 10, and 8, how are they being selected? There is no answer for that. It's random. There is no answer. It's randomly selected. Randomly selected. So now this simple random sampling methodology will be utilizing many other sampling methodologies also. You will learn a couple of them in a little while, where once you have a particular pre-selection criteria, so for that selection criteria also, you can put the simple random sampling and select the final sample. So the whole idea, whole takeaway from this simple random sampling is that it doesn't necessarily have a methodology, but some mechanism like a random number generation machine or a table or a registry, or you give some numbers based on the attendance. The sample can be selected. Very easy and a powerful tool. It has been widely used also. Okay, the second one, systematic sampling. Excuse me. Systematic sampling. Now we are still under probabilistic sampling. After simple random, we're going to discuss the systematic sampling. Okay, let's read the text. The researcher can determine the sample size, simple n, from the population, capital N, and then determine the sampling fraction. Sampling fraction. What is this? Target population over the required sample size shall be used to calculate the sampling fraction. For example, if an airline has 400 passengers, if an airline has 400 passengers and 50 would be the sample size. That means, let's say, for this particular aeroplane, there are 400 passengers are going to come on board. And you need to select 50 to do some sort of a survey. Let's say the airline satisfaction survey. So under the systematic sampling, if you're going to practice, how are you going to do it? You're going to put them in a line, maybe their seat rows, maybe their attendance order, any order, and pick every 8th passenger on the sequential order in order to build the sample. So that means, okay, you fine. If I elaborate this, it is going to be something like, okay, you select the first person, and then you have the second, third, likewise up until the 8th person being selected. Now these two are going into our sample. Moving on, the 16th person going into the sample. Likewise. What about all the other second, third, 9th, 10th? No, those are not going to be selected. These chaps are going to come into my sample. 24th, 32nd, 40th. These passengers are going to create the sample of 50. 50 passengers out of these 400 airline passengers. It's systematic, it's organized, it's sequential. It's a very effective manner. Once again, I mean, does these methodologies is going to, forget about all this initial discussion on whether the selection biasness is going to be taken away? You can't really be guaranteeing about that. Why? Let's say, now let's say this particular survey about the airline food, and you are going to serve, let's say, 80% of your meals are non-vegetarian, and there will be only one meal of the vegetarian. And then you need to do this survey to find whether people are happy about your vegetarian or non-vegetarian meals. Sorry, okay, let's say now, I mean, they're giving an emphasis on the meat items. What if this random eighth person is a vegetarian person? And then you give the questions about asking about meat, chicken, the beef, whether you're happy with the pork presentation. I mean, what can the answers be given? All empty, null. Why? The random eighth person is going to be a vegetarian person. Can't it happen? It can happen. There's a thin probability, maybe 1%, 0.1%, but there's a probability. So that's why I'm telling you. Oh, okay, fine. The probability is very rare. I mean, when you put everybody together, how can be the 8% is going to be a vegetarian? It's not very practical, but it's a probability. Okay, but those probabilities are minimum, students. That's why these methodologies are being practiced. When you take people and try to do a survey, do a sample, when you do that in a systematic way, in an orderly manner, ascending order, with a numerical numbering, with the attendance registry, with the employer registry, then when you try to select people in a numerical orientation, then that is going to be very much superior to what we learned so far. That's why systematic sampling is going to be widely used in factories, surveys, employee satisfaction, the feedbacks. That's why they have been very popular. Systematic sampling. The second one. Okay, stratified sampling. Now here you should recall, or previously what we learned is a quota sampling. We told you that there are some relationship between stratified and quota. Right. Population should be divided into homogeneous and mutually exclusive groups called the strata. So this, the words homogeneity, mutually exclusive, those are all going to give you the same idea. That means one group will only have the characteristics of one particular element that we are looking at, like age, gender, geographical segment. For instance, if you're taking these people from different provinces, okay, fine. White will be western, red will be, let's say, eastern, and the blue will be northern. If you take based on, let's say, age, younger, middle, and the older, those are going to not occur in cross strata. The one strata, one group will have one particular element that we are looking at. Now, fine. Now, from each strata, collect sample by simple random sampling or systematic sampling method. You see, I told you, stratified sampling, the only difference with the quota sampling, in the quota sampling, you do the same thing. You come here with the same intention with the groups, and then you select sample from these groups based on your definition, based on your preference. But here, once you come to this particular place, you can either use simple random sampling or systematic sampling to collect data from each sample. So from in front of, so from this white and red and blue groups, inside those groups, you will practice another sampling methodology to select the sampling method. Okay, so this is the stratified sampling methodology. One could ask you the question, okay, so now tell me what's the difference between the stratified and the quota? Okay, fine, both are trying to, select the sample based on the grouping first. The stratification, the grouping, mutually exclusive items are going to come into individual groups. No mixing up. Once that is been done, quota sampling, a non-probabilistic method, what it does is that it will try to, choose items from those groups based on the quota defined by the researcher. The quota can be anything. It could be a scientific methodology, it could be a preferential methodology, no harm. So it's a quota. But the stratified sampling, it is going to give you nothing but the elements in the final sample will be coming from these stratums or the groups based on another probabilistic methodology like simple random or systematic sampling. So for instance, inside the red group, how does this one person come? It is by inside this red group practicing a simple random sampling. So that means you may give number 1, 2, and 3 for these elements, and 2 will be selected using the simple random sampling. Similarly, number 31, 33, and 37, and 37 will come here based on the maybe a systematic sampling method. So the stratification is going to be a much more scientific method, even compared to the systematic sampling that we learned a little moment ago. Why? Now here also, you remember my silly example of vegetarians being selected as the 8th person could be eliminated if you do this. You stratify them, then you know, okay, the criteria that you're focusing on is been addressed, but in a now much more scientific manner, then you go for the next level selection. Yeah. But don't forget the fact that this stratification is also being done in one particular angle, one particular qualitative factor only can be embedded in a one stratum. Now look at the two working examples that I discussed. Either they could be from provinces. I call them from Western province, Eastern province, Northern province likewise. Then I told you another stratification could be done by age, young guys, middle-aged people, and the older people. Now inside these three white phases, they could be comprising from, let's say, if you do this stratification based on provinces. So from the northern province, three older gentlemen will be these three white faces, right? I mean, you don't really know how these elements is being selected to my sample. Why? Okay, fine. The white faces will have young guys, old guys, and middle-aged people. Fine, that's not a difference. But look at the end sample. You still do a simple random sampling, right? Or a systematic sampling. Now, for those sampling methodology, you still have this selection bias. Unfortunately, due to being given equal probabilities, so the final white figures in my sample will have maybe three older gentlemen. So still, I would say nothing has given a perfect answer for a perfect sampling methodology. There's no such thing as a perfect sampling methodology. There is one only perfect sampling methodology, that is, forget about the sample, you go and access the entire population. Then the sample, simple N becomes the capital N, and this none of these methodologies or biases will be occurred at that point. Okay. Last one, another stratification or group-oriented methodology, we call it as the cluster sampling. Cluster sampling. Okay. Now here, what we do is we divide the population into groups or clusters or stratas, no harm, and obtain a simple random sample of clusters from all possible clusters. Now here, you see this red, green, yellow, blue, and purple are the 5 different clusters that will come into your classification once you do the grouping from your population. And then out of these five, you select only 3 groups. So how do you select those 3 groups? It's by a simple random sampling. You give them a group, something like group 1, group 2, group 3, group 4, and group 5. Then you take a dice or something like that, a random number table. Then you select number 1, 4, and 5, and this is going to be my sample. This entire cluster, entire group is going to come into my selection. Now this is going to be my sample. This is my sample. Okay, about blue and yellow, sorry, no opportunity being selected. But how do we select these 1, 4, and 5? It's based on a scientific methodology. What is a simple random sample? Second word, above is called as a one-stage cluster sampling. While if we conduct another simple random sampling from the selected clusters, it can be defined as a 2-stage cluster sample. Now, what is that? I told you at the beginning that now the simple random and the systematic can be combined with other sampling methodologies, right? So this is merely you select the entire cluster, but from the cluster 1, cluster 4, and cluster 5, you try to select maybe 2 elements from each item. Do another simple random sampling inside the cluster. Inside the red, now you select 2 reds. From here, you select 2 reds. And from here, you select 2 greens. Here, you select 2 purples. Assume that this is purple color. Now, this particular sample will be named as a 2-stage cluster sampling. Inside the cluster, you practice another random sampling, and then you select the final sample. Okay, quickly try to recap. Yeah, now this is going to be a good recapping graphical illustration of the probabilistic sampling methods. So the simple random sampling, look at the picture. You don't have a scientific methodology of a natural order, something like that cannot be observed. Random, purely these figures has been selected. About systematic sampling, every n position. You put them in an order, put them in a queue based on a scientific or non-scientific method, and then you select the nth item to be much more effective. Stratified, you cluster them, and then you practice another simple random sampling inside the stratums. The cluster sampling is nothing but the entire clusters will be taken into the sample. Now, the items that are rounded are the items that is going to come into your final sample. Okay, it's a good recap and a good graphical illustration of the probabilistic sampling methodology. Simple, random, systematic, stratified, and cluster. Yeah. Quickly recapping, what are the 4 items that we learned so far? Convenience, based on your easy of access. Judgment, another form of convenience, but then again, purposely you select the sample. Quota, you group them and then you give some sort of quota for the individual items based on any methodology of your choice. Snowball, 1 item, 2 item, 4 item, 16 item, likewise. The next person will recruit the next batch of people. Those are the non-probabilistic. Probabilistic, simple random, based on random number table, based on a dice, based on anything. A random generation mechanism will choose the items. Systematic, nth item. Stratified, you cluster them, and inside the cluster, select based on the simple random. And cluster, the whole clusters is going to be taken into the sample from multiple clusters. Those are the 4 and 4 widely used probabilistic and non-probabilistic sampling methods. Okay, before we wind up and go into the questions, now once we do this sampling, students, I told you at the beginning that there are going to have some natural issues. So the broader classification sometimes that you can put into are sampling errors and non-sampling errors. So sampling errors are errors that are going to come because of the fact that the entire population is not being chosen for the sampling. The entire population is not being chosen. When a sample is selected based on a non-probabilistic method, which typically how it happens is the non-probabilistic method. Why? We told you at the beginning, if it is probabilistic, you need to know the items in the population. If it is non-probabilistic, you don't necessarily have to know the items in your population. So if you practice something like a non-probabilistic method, then there is going to be a problem of the entire items is not being chosen into the population. Not chosen, not being given an equal chance to be chosen into the population. Sorry. So those errors are the type 1, the sampling errors. The other type is non-sampling errors. That means, okay, fine. Now, assume that you haven't practiced any non-probabilistic method where you're giving a chance to, you're not giving a chance to everyone. Now, assume that problem is taken away. But still, these couple of errors, these are, once again, these are not the only issues. There are many other issues under many other names, but these are few casual examples for us to discuss. Coverage error, where a sample is not representative of the population. That means something like you go to a village and then do a sampling on a particular voting pattern, and that entire village is being biased to one particular candidate. So that instance, that particular area is not going to cover the entire population. There are many other population fractions geographically dispersed, but they are not being taken into that particular sample, that particular village. So the coverage. when the sample is not representative of the entire population. Second one, measurement error. Incorrect and leading questions. Now, you have given an equal chance to everyone to be selected, but then again, uh, the questions that you have been put into the place are going to give them a leading answerability or something like a hint hidden in the question. Something like, do you think that education is going to lead to better human qualities? Do you think? Other than that, if you put the question like, what will lead to better human qualities? Your upbringing, the association, education, and then maybe let's say geographical something. Now, look at these two questions. The first question is going to give you a leading answer. Do you think education is going to cultivate better human qualities, something like that? Obviously, I mean, that is what we have been brought up with, isn't that so? We have been brought up with, okay, you become educated, and then eventually everything will be better for the society, for you and everyone. So those kind of questions, students, are going to be not very good type of questions to be put it into a statistical survey. Leading questions. In contrast to the second methodology, what will lead to better human qualities, and give a couple of answers. Okay, fine. Now different answers and different responses will come. If you put such kind of questions in a particular survey or for a particular sample to be selected, then obviously we call those errors as measurement errors. Measurement errors because of incorrect or leading questions that can happen. And another form of non-sampling errors is non-response errors. It's simple as that. The wording itself has the idea. That means either your respondents will give you fraudulent or will not respond at all. Either fraudulent or will not respond at all. That means now sometimes you put up 52 different questions and give them a selection to not to answer everything. What will typically happen? Okay, they will only give you answers to the compulsory questions, and then the elective questions they will think, fine, okay, it's not necessarily practical to give an answer to all 52 in 10 minutes or something like that. Then they will omit and go. No answers. No answers. Asking about some sensitive issues like what are your qualifications, what is your wealth level, what is your salary, people will give you fraudulent information, obviously. These are some bad questions to be put it into a survey or a sampling methods. Right. So these are, again, to recap, some of the issues that can happen with sampling. Again, I reiterate, why do we do sampling in the first place? It's merely because of the fact that we need to get some access to the population, but we don't have the entire access. So what do? We try to do some assessment and get a set of items so that the population can be derived, the population can be explained. But then again, once we are trying to do it, once we are trying to practically do it, there are some problems that is going to come into play. So these are some of these sampling issues, sampling errors and non-sampling errors. Few examples of non-sampling errors are coverage, measurement, and non-response errors. That's about pretty much of it. Now here, before the past training questions, I've just put one of these classic examples. Now assume that you are trying to derive a sample from a particular population, and then let's see what is going to happen when you're finally trying to do the sample. So look at my first target population. What is my target population? University students between age 25 to 35. That is an example that I'm going to try to cover up with. My target population is going to be university students with the age between 25 to 35. So once I try to do the sampling, what is my accessible population? So students who are attending to the class today. Let's say I only have one day to go and get the sampling, and then I am selecting Monday or Tuesday. Let's say I go into this particular university on Tuesday, not necessarily one particular university. I go to University of Morocco on Tuesday, then University of Colombo on Monday, likewise. I will only attend one particular day. If that is my business case, the accessible population is the students that I attended the class during the day today. So I can put up some inclusion or exclusion criteria for my sample. I mean, this is nothing to be practiced at the exam, but then again, I'm just trying to show you some of the practical issues that will come when you are really trying to do the sampling. I will put up my inclusion criteria as international students. And then, okay, fine. Then I have put my questionnaire on English base. I don't have really understanding on Mandarin or Tamil or Hindi or any other language. Then I have to put up some exclusion criteria also. As non-English speaking students, I have to be regretful and not to be selected. Now look at my sample. I go to university, try to go to a particular class, and then I filter them with the age 25 to 35. But there may be some students who are attending to the university on that day, but not particularly on the day that I went. Fine. Then I focus on particular set of students. I don't want the local students. I will only focus on international students. That's another set of criteria that I can filter into. And depending on some practical issues, I may have some exclusion criteria also, where the non-English speaking students will be taken away. Now those 20 students or 25 or 15 students are going to be my sample. Now see, why I just try to put this slide as the possible issues with sampling is the fact that now there may be many other students between 25 to 35. And there may be like hundreds of students who attended to the university but not attending the day that I went. And then there may be many more international students. And then there may be many more non-English speaking students in the population also. So unfortunately, I may have been left with the only 15 or 20 students that I had compelled to forward my survey and get some responses to my sample and been selected as a sample. Okay. Now see, these are some of the practical issues when I really wanted to do a sampling. Now it's not really be easy. It's not going to be very comfortable to do a sampling like this. But then again, now what are the solutions? Now one might say, okay, whatever the methodology that this lecturer is proposing, he's coming up with different issues. Now, aren't there a solution, a universal solution for all these things? There are many solutions. One would be you could do multiple samples, isn't that so? Now your issue is with selecting one particular sample. But what if you do 10 samples and then take the simple average of any results or arithmetic average or any other statistical methodology on those 10? Or another good methodology would be you do the same sample again and again. Not that on the same day you do the sample, you do the sampling at multiple times. So certain samples, it's very important to do at different timing or different geographical locations. Let's say you do something like a soil test. You can do one test in Asia, another test in Europe, likewise. Let's say you do some studies on something like weather patterns. Of course, then you have to do a huge number of days in huge number of weeks to get a better understanding. You can't really be happy with this July 3rd week sample to be the only sample. And you can mix up different methodologies also, which will give you better results. Rather than you try to, be limit with one particular sampling methodology. Let's say you think, okay, stratified sampling is going to be my best methodology. You don't necessarily have to be stopping with stratified. You collect one set of data from the stratified methodology, one set of data from Snowball methodology, and then you have many results. And the outcomes can be combined using statistical methodologies, which is applicable of collecting multiple data sets. So those are the only solutions to streamline or to stringent your criteria on the selected sample. Okay, fair enough. Excellent. Right. With that, I think we are done with the theory part of the day. So before we, yeah, so we just completed up until the possible issues with sampling. Fine. So before I move into, yeah, we have a good 20 minutes to discuss the past paper questions today. I have ample number of questions. If at all you have any doubts or any questions to be discussed, I can stop for a minute and you can post anything or switch on the mics and ask any question. Okay, good. As always, you can drop an email or, you have the luxury of watching this video again once the advisor shares it with you. So hopefully, without further ado, let's try to, then go to the questions and see what sort of angles will be tested at the examination. Hope that is fine with you. Okay. I quoted very few past papers in the last 5 to 6 years. Let's try to take you through one by one. So typically students, now in the entire previous past paper set that we discussed on the very first lecture, we didn't have much more questions. So typically what I've done was I've just taken the questions with the demarcation, something like this. Now this implies that this is question number 8. If I only have, let's say, something like a Roman number here, that means this is question number 1, part number 8. Yeah, question number 1, part number 2. Okay. Having said that, let's read the question and we'll try to come up with an answer. Yeah, let's take the question number 2 again. Firstly, that means question number 1, part number 2. Now, is it a compulsory or elective question? It's a compulsory question. Okay. In a sample survey, every 10th item from the list of all employees of a factory are planned to be interviewed to find out their views on the transport facilities. Okay, every 10th individual from the list of employees, from the list of all employees. List of all employees. That means seems to be a probabilistic method, right? A factory are planned to be interviewed to find out their views on the transport facilities. The name used to describe this sampling method is stratified, systematic, quota, and cluster. What do you think? Okay, good. I think correct. A lot of you are getting it correctly. It's a very easy answer. Systematic sampling. But the whole idea is that, see, it's a probabilistic method. The doubt is being taken away. You can figure out, fine, okay. The entire population is being taken into consideration. So that means it has to be some sort of a scientific methodology. If it is simple random, they could say simply, I'll take some random people from the list. No. If it is stratums or clusters, they have to cluster them. They have to group them. Okay. That means obviously the other methodology that we discuss is a systematic method. Systematic sampling is the answer. 2 marks, easy. Question number 8. Now this is where, now similarly during the past couple of papers, this year also we could observe that brief explanation. Briefly discuss the following concepts related to statistical information. Now this is where students, you have a bit of a flexibility to, once you say the word discuss, that means you can define, you can put up some comparisons about the items being questioned. First one, dispersion of disbursement and measures. Third one, principal measures of central tendency and positively skewed distribution. These are future lessons for us to learn. Look at the number 2 and number 4. What is number 2? Sampling errors and non-sampling errors. Now here you can broadly define what is sampling, why do you do sampling, and once you practice probabilistic and non-probabilistic sampling methodologies, what sort of errors that is going to come into play, the distinguishment between the sampling errors and non-sampling errors, and maybe put up some typical non-sampling errors that you can observe. That will give you ample 5 marks. Since we just discussed about these theoretical parts, I ideally believe that we don't have to spend time and do a write-up. But bear in mind, in an answer like this, what do you need to structure? First things first, orientation and order. I really imply, don't really go and write a chunk of words where the marking examiner will have a bit of a problem to identify where your answer is being focused into. Don't do it. If you don't know a particular answer, not writing it is the best thing to do, rather than agitate somebody to an unwanted manner, so that they will try to skim and try to find the answer of this particular student in a very difficult manner. Do you think that you can bully someone having a better understanding than you by writing some gibberish? It's not going to be really practical. So I really implore, if you know something, don't really try to put them into a bulk of words and try to shoot them at the examiner. For this part number 2, what I will do is I will try to cluster my answer into half a page, or maybe maximum 1/4 of a page, and maybe put up some headings: sampling and population, and then possible issues with sampling. You then cluster under sampling and non-sampling errors, and then under sampling errors you put up a small writing. Under non-sampling errors, put some examples into non-sampling errors. And then maybe some more wording as to how you eliminate these. That's a good discussion on sampling errors and non-sampling errors on a broader scale. Okay, great. Okay, on the systematic and stratified, yeah, you start up with the systematic, you put them in a line, and then you say, okay, every nth item is being selected, and why you do it, and why it is superior to any other methodology, and what are few possible issues with systematic, and then move on to stratified sampling. Call it the grouping part, and draw some relationship between this and quota also, if you have time. And then under stratified, how to do the simple random or systematic inside the stratas and do the final sample. This explanation is all what is needed for a good 5-mark question. Okay, fair enough. On to the next question. 2019 September. Statistics involved in various types of data collected from various methods and sources. Briefly discuss the following concepts related to the statistical information: simple random sampling and stratified sampling. Now, I really implore to show you the pattern. See, in the question number 8, there is some question been popping up in the recent past 2 years in one of these sampling methodologies that we typically discuss and in generally that simple random sampling, a probabilistic sampling methodology that you put it into a random number generation mechanism to select the items from your population to the sampling, and that is a probabilistic sampling method. Stratified also probabilistic sampling method. You do the same thing about stratification, right? But be careful, extremely be careful on what is being asked here. Now, the word briefly discuss gives you some leeway. But if at all you see something like do a compare and contrast, your answer structure is going to be somewhat different. Okay. Right. 19 September, question number 1, part number 2. In a sample survey, every 10th item 10th individual from the list of employees, factory. Now, if at all you really looked into this question versus the question that we discussed, pretty much it's the same thing, isn't that so? I hope you don't have to really give me an answer here. The name used to describe this sampling method is the systematic sampling. So, I mean, credit to the examiner and students have been given some opportunities to, if at all you go through the last couple of exam papers, then that means you are in a better understanding close to the exam what sort of a pattern of questions being tested. Okay, next question. 19 March, again question number 8. That again asked for a briefly discuss the following concepts. Simple random sampling, certified sampling, we have discussed a very similar question. Measurement error and non-representative error. Now this is where you remember that we discussed about some non-sampling errors, measurement errors due to leading and incorrect questions, non-representative errors, because people can be giving you the fraudulent and no answers, no responses. Now these are again can be discussed with a bit of a introduction into why the sampling is being taken into place and why typically these things can be seen in the nature. Likewise, you can put up a decent answer, I believe. Right. 18 September, part number 8, again briefly discuss measurement errors and non-representative errors in conducting surveys. Similar to what we see in 19 versus 20 papers. Similar question being put it into the adjoining papers. For 5 marks, I think you can do justice right now. 18 March, briefly discuss the following concept. Simple random sampling, stratified sampling. That's why I told you at the first class, some of these questions we'll try to discuss. Some I will leave you to try it on your own and then come up with an answer, which is the better way. And some questions we will skip merely because of the fact that they can be repeating and they can be the same question being trying again and again. 17 September, now this is a good MCQ, question number 1, part number 6. Suppose you are performing stratified sampling on a population and have divided into strata of different sizes. You can make your sample selection by A, selecting a random or equal number of elements from each stratum. Okay, now here, hold on. The question has told you that you are performing a stratified sampling. Okay, now you have done the grouping. Now then you are going to do the selection. First, A says selecting a random or equal number of elements from each stratum. B, selecting equal number of elements from each stratum and weight the results. Okay, fairly good. C, selecting number of elements from each stratum, proportionate their weights in the population. What do you all think? You do the stratified sampling, then that means the population is now being divided into different groups. Now this is done. 1, 2, 3, 4, and 5. So you are going to select the sample. The first A says selecting a random or equal number of elements from each stratum. Let's keep that for a while and let's focus on B and C and try to see whether we can come up with whether any errors in any answers. Selecting equal number of elements from each stratum and then weigh the results. Now once you do the weighting, that is going to give you the perfect stratification. Isn't that so? If at all you have the different some sort of a biasness being created, this is going to be moving into the quota sample, not the stratified. Look at the answer number C. Select a number of elements from each stratum proportionate to their weights in the population. Now, both B and C are going to give you a bit of the same idea, isn't that so? You select the items, either you weight them, or you take the proportions and then take the items. Now this is the broader idea of the stratified sampling. But if you really look into the answer number A, what's the only issue that you can highlight there? The only issue is that selecting a random or equal number of elements from each stratum. If you do the some sort of a equal number from each stratum, that means some stratum will have a higher number of items, isn't that so? Let's say my first stratum will have 10 items, and then the second stratum will have only 2 items. Then if I select 2 items as the selection to my sample, second stratum will have the entire things coming in from the first stratum. I will only get 2 out of 10. So this equal number is not going to be a very good selection for a stratification. But if you do a weighting or if you do a proportionation, I think that is going to create a bit more better selection for the stratification. So if at all I've been asked to select what is the more correct statement from the above, I can go for answer number B. Only B and C are true. That's the official answer. 17th September, question number 1, part number 6. Okay. So now these are a bit of a tricky questions for you to understand clearly. I want to implore the fact that go through the question one more time on your own. 17th September, I have a few more minutes to practice with more questions. Now this is something which we can skip. Briefly discuss the following concepts: cluster sampling and stratified sampling. I hope we went through enough theories to discuss these two items. 17 March, question number 1, part number 4. What is the best sampling method to be used in a survey? Related to wages in apparel industry where there are male and female workers. That means it gives you a bit of an implication. Okay, fine. This male and female workers are going to have 2 different wage structures, isn't that so? So if you do something like a random sampling, then it is going to create a problem. Why? Your sample will only be selected with a bias. And if you do something like a systematic sampling, now this is something which will be very useful if you're doing a survey of a particular group of big registry, and out of that registry you are going to do some sort of a selection. Now our 2 relations, quota and stratified, are there hand in hand, and we know always giving a probabilistic oriented sampling is somewhat better than giving an unprobabilistic method. Why? Because then you are going to know entirety about your population. So a good answer for this question will be answer number A, stratified sampling for this particular survey. Why? Apparel industry, that means it is defined, it is going to be a probabilistic method, obviously much better than an unprobabilistic method. And since there are male and female workers, giving you an implication of a stratification or a group, that means the stratified sampling is going to be a better methodology. Now this question, look at the nature, compare and contrast. Now this is not going to be somewhat like what we answered so far. It's not going to be easy to answer something like this, because then for you to do this question, it's going to take you a lot of time. Why? Now you have to do the similarities and differences. That's the broad idea of compare and contrast. Now simple random sampling, stratified sampling, we know, but here students, you can't really discuss about this is how sampling comes into play, so and so. It's not the case. You have to write some similarities between these 2 elements, systematic random and stratified, and then some differences also. So if I structure this question, I would structure it in a way that I will talk about systematic sampling and stratified sampling, both as probabilistic oriented sampling methodologies. We'll start with that. And then we will discuss both the methodologies using scientific and systematic methods. Both knows about the population. Likewise, these are some of the compare. And then when you do the contrast or differences, then you can distinguish between these two. These two are having different characteristics. Then justify about this is what systematic does, this is what stratified does. Okay, fair enough. So that's how you do a compare and contrast. So don't ever get into the chat that you open the question paper, jump into question number 8, then you do the entire answering with the brief descriptions. No, be mindful of what the examiner is asking about. Part number 4 also, measurement bias and non-representative bias. Now, sampling situations, you can start with the sampling errors and non-sampling errors, then you can come into the different explanations on non-sampling errors. These both of these are non-sampling errors, and then you can discuss about the similarities and differences. That's how you should structure. Okay. The rest of the questions, let me invite you to try it on your own, but briefly let's try to skim through before we wind up for the day. Compare and contrast. Now see, 2016 paper also going to ask you about not a brief description, but a compare and contrast. Probabilistic sampling techniques, simple, random, and stratified. Measurement errors and non-representative errors. MCQ question, 16 March. Part number 5. In a sample survey, all employees of a factory are planned to be interviewed to find out their views on the present retirement benefits. This is a good question. I want you to try it at home and then probably come up with an answer for the next lecture. It's a bit of a tricky question, I would say. Try to read the theory, if at all you have a doubt. See a question over here. Will you be sharing the presentation? I believe this presentation is also already been shared with you by the IBSL staff. Just check with them one more time. If you haven't received it, I think you should be receiving it through the Google Classroom share space. All the historical lectures are there. Check with the IBSL staff just for the lecture slides. They will be shared before the lecture, of course. So this question, students, 16 March, question number 5, I want to try it on your own and get up with an answer for the next one. Okay. Had a detailed day, a lot of talking, and you didn't have much to be responded or have much questions to be tackled up with. There are some interesting questions coming up in the numerical areas. No worry, these are merely theories. Still, we are the lesson number 1. Lesson number 2 is going to be on presenting data. So that is also not going to be major numerical oriented. But from lesson number 3 onwards, where we are going to start with the numerical dispersion measures like mode, median, and mean. And then we are going to discuss into probability. Now, those are the instances where you will get interesting questions, like numerical questions, where you are going to use the calculator, obviously. So did all of you manage to get a calculator? I believe that for those who didn't have a calculator may have get a chance to buy a decent calculator, a scientific calculator, a non-programmable, silent. Obviously, you can't go to the examiner and make beep beep sounds where you're going to disturb the other students. So make sure for those who didn't have a calculator that you will have a calculator after the next class. So the next class also you don't really need a numerical one, but after that you will necessarily need calculators. And obviously, students, now although we are practicing for this mathematics and statistics oriented paper, once you get your calculator, I really implore that all the scientific calculators have some advanced methodologies. So for instance, if you have been asked to calculate something like let's say a mean of a particular data set, obviously you and I, we both know we take everything, add them together, divide by the number of items. That's a simple average. But if you've been asked to calculate the variance, then you have to calculate the mean, take the individual item minus the mean, take the square and then take the square root. Now, it's a calculation. You will learn it. Don't worry, it's a calculation. But if you familiarize yourself with the calculator, I really want to show you that there are modes like the stat mode and the variable mode and the data mode in all these calculators, where you can get the calculator to do the calculation. But you can't put that answer in the exam paper. Be very mindful. You can't open question number 6 and tell you, okay, variance, the answer is 2.7. 0 marks. No, examiners will not give you marks for any correct answer without a methodology. Forget about that. But if at all you practice the calculator much better, at the examination, you will be at a much more better position to cross-check your answers with the use of the calculator. So that's why I really want to spend another couple of minutes and highlight the fact that you get the calculator. I don't really want to recommend a model and stick you to one particular model. Buy whatever possible, or if you have a calculator, that's perfectly fine. Let's go ahead with that model. I'm sure a lot of calculators will have these modes that I just talked about, the stat mode and the data mode. If you have doubts, YouTube is the best answer. Just YouTube on the calculator's model and the manual will get ample explanatory videos on the functionality. Okay, sorry about the couple of extra minutes. If at all you have any other questions to be discussed, I am at your disposal. I can answer any. Otherwise, I can wind up for the day. You can use the chat, you can use the voice, or if you prefer to ask by email, I'm at your disposal again. All good. So shall we wind up for the day in that case? Okay. All right. I believe that these are easier theory parts to conclude. The the better areas will be definitely coming up with the next couple of lessons. So let me wind up for the day then. Have a good evening and always stay safe. Thank you.